to do, which had to do with the mean value theorem. And so basically, you saw that the area of a region under a curve is greater than the area of an inscribed rectangle and less than the area of circumscribed. The mean value theorem of integrals states that somewhere between the inscribed and the circumscribed, so we're talking about, here's the inscribed rectangle and this is circumscribed outside of the curve of outside of the area. Between the inscribed and circumscribed rectangles, there's a rectangle whose area is precisely equal. So that's where this point C comes in, to where the areas will be equal. So we take the integral from A to B, so here's A to B, of our function f, here's our function, and this is, so we find this integral here, and then we take f of c, we substitute it into our original function and multiply that times the difference between our interval A to B, and then we solve from that point. So we're going to take a look at problem number 56. Here we go. So here we have number 56. I'll write it down here and then I'll switch it to the board. Is f of x equals to 4x cubed minus 3x squared, and that's on the interval from 0 to 1. But since this is the homework, I'm going to change this to interval from 1 to 4. So this is number 56 modified. Okay, so I'll share my screen on the board. So here we are, and we're saying the mean value theorem is okay, so we're going to take okay, so what we're looking at here is actually the average value of a function. So we did the mean value theorem already. So what we're looking at is the average value of a function, which has to do with where we're taking the value of f of c given the mean value theorem, where the integrals are called the average value. So that's where we're taking the average value of what's inside the area versus what's outside. So the definition of average value of a function is closed by a to b, where the average value f is 1 over b minus a times the integral from a to b for f of x dx. Okay, and so we're going to look at problem 56. And so here's our board. So we're going to look at, here's our A is 1, B is 4. So this would be 1 over 4 minus 1. times the integral from 1 to 4. And then we have here 4x cubed minus 3x squared dx. And so this will be 1 over 3. 4 minus 1 is 3. So this will be 1 over 3. And then, so the integral for here will be,
Can you bring your board up a little bit?
yeah, there we go. So this will be the integral from 1 to 4 for 4x cubed dx minus the integral from 1 to 4 for 3x squared dx. So I took this and I split it. Okay, and so all this is multiplied times 1/3. So this 4 can come out. So this would be 1/3. And then the 4 that can go in front of that, integral from 1 to 4 x cubed dx. And then this 3 can come out in front of the integral from 1 to 4 x squared dx. Okay, so from here, this will be 1/3. And so we're going to add 1, right? So this will be 4 times x to the 3 plus 1 over 3 plus 1. From 1 to 4 minus 3. And then this will be x 2 plus 1 over 2 plus 1. From 1.
Are you adding a 1 because it's in a formula?
Because when you integrate, you add 1. When we differentiated, we subtracted 1. So integration is the inverse operation to integration is another word for is the antiderivative. So you're adding, when you integrate, you add. So
okay.
So this would be 4. So this would be x to the 4th over 4 from 1 to 4 minus 3 times x to the 2 plus 1 is 3 over 3 from 1 to 4. Okay, and so here the 4s can cancel, right? So the 4s can cancel here, and so we've got 1/3 x to the 4th from 1 to 4. And then here the 3s can cancel, and so that's x to the 3rd from 1 to 4. Okay, and so now we've got 1/3, and so this will be 4. So we're substituting 4 in minus 1. So this will be 4 to the 4th minus 1 to the 4th. Okay, and so that's this minus 4 to the 3rd minus 1 to the 3rd. Okay.
Where did you get -1 at?
Well, you substitute 4 in, right? Here, that's 4 to the 4th. And then you substitute minus 1. Okay, so before we worked with 0, right? And so this would be 0 to the 4th, and so we just dropped the 0. But this isn't 0. We had a 1, right? So we don't have a 0. So now we have to subtract this. Okay. All right. So this will be 1/3. And so 4 to the 4th is 256 minus 1. And then 4 to the 3rd, that's 64 minus 1. Okay, and so we get 1/3. 256 minus 1 is 255. 64 minus 1 is 63. So that's 55 minus 63 is going to be 1/3 times 192. And so that's 64. And that's our answer. Okay. Questions with that? Okay, so that's all there is. That's the last of for chapter 4. All right, any questions with that? The people that just entered the class, I haven't gotten you on attendance, so make sure I get you on attendance before you leave today. All right, before we finish up. All right, so let's go back to our, let's take a look at the PowerPoint notes for 5.1. All right, and 5.1, chapter 5, we're getting into logarithms. And so we have natural log, we're going to do some review of natural logs, the natural log function, and differentiation. So we're going to develop and use properties of natural logarithmic functions, understand the definition of the number e. Find the derivatives of the function involving a natural logarithmic function. Okay, so properties of natural logarithmic functions, the natural log function of the following has, so when here's y equals to natural log x. So we know that exponential graphs, e to the x, they go up. They go through, they start off small, go through 1, and then they take off and go move at an exponential rate. Whereas logarithms, they're the inverse. They're going to start where the vertical asymptote is at y equals 0, and they continue on in negative infinity to going downward for y's, and they come up and they intercept x at 1, and then they start to flatten out. But they don't completely flatten out, they continue to go up. That's why the range is negative infinity to infinity, because they don't completely flatten. So the function is continuous, and it's continuous, and it does increase, and it is 1-to-1, where if we were to apply the horizontal line test, no matter where you draw that horizontal line, it only intersects the function at 1 point. And so the graph is concave down. All right, questions with that? All right, so no more review of logarithmic properties. If a and b are positive numbers and n is a natural number meaning counting numbers, right? 1, 2, 3, and so on, then the following properties are true. Natural log 1 equals 0, because if we applied the inverse to that, e to the 0 would be 1. Natural log meaning log base e. Natural log a to the n, we can bring that exponent down, and so that's n times natural log a. So that's any logarithm. And so natural log applies to the same properties as any logarithm because it's just log base e. So natural log a times b is natural log a plus natural log b, whereas natural log a over b is natural log a minus natural log b. So what I like to say is anything in the numerator is going to get a plus, anything in the denominator is going to get a minus. All right, questions with properties of logarithms. Okay, so let's take a look at some problems. In here, in the expression 21-30, use the properties of logarithms to expand the logarithmic expression. And we're going to take a look at problem number 27. So I'm just going to write this down here. And we have a natural log from the square root of x minus 1 over x. All righty. And so we'll switch to the board. Okay, so here's our problem number 27. So the first thing we're going to do is change the radical to an exponent. So x to the 1 over n is the same as n x to the n power, where the root goes in the denominator. So we're going to go backwards. We're going from from radical to exponential. Since this is square root, we don't normally put a 2 here, right? It's implied that it's a 2. So this will be natural log x minus 1 over x to the 1/2 power. All right, questions with that? And so now with properties of logarithms, right? When we have an exponent, we can move that exponent down. So that's what we're going to do with this 1/2. So this will be 1/2 natural log x minus 1 over x. Okay, so from here, we're going to apply the property of logarithm where natural log a over b is natural log a minus a natural log b. So that's what we're going to do here. But when you do that, this 1/2 is for the entire expression, so you have to make sure that you use brackets. So this would be natural log x minus 1 minus natural log x. And so you could write it, write it like that, or you could distribute that 1/2. And so that would make it 1/2 natural log x minus 1 minus 1/2 natural log x. And so you may see the expression either way. All right. And so that's all there is to expanding that logarithm, okay, that natural log. Any questions with that? All righty. So, all right, so let's go back to our PowerPoint. I'm going to go ahead and exit out of it all. Okay, so let's take a look. Here we're writing an expression of a logarithm of a single quantity. So here we have the logarithm expanded out, and we want to condense it to a single logarithm. So we're going to look at problem number 33. All righty, so I'll just write this down. Number 33, and we've got 1/3, and then a bracket, and we've got 2 natural log, and then x plus 3 in parentheses, close that, plus natural log x minus natural log x squared minus 1, and close that parentheses, close the bracket. Okay, so switch back to the board. All right, and here we are. Okay, so when we had here natural log a over b, we subtracted natural log a minus natural log b. So this time we're going back the other way. And then if we had natural log a to the n power, we brought that n down, n natural log a. So we're going to be going back the other way to condense it. So first thing we do when we expand, the last thing we did was bring the exponents down. when we're condensing, the first thing we do is we go ahead and bring the exponents back up. And so this is the only one. So this will be 1/3 bracket. And so this will be natural log x plus 3, close the parentheses, squared. And then we're not going to do anything else to the rest of those. Natural log x minus natural log x squared minus 1. Close parentheses, close the bracket. Okay, so now anything that's got a positive goes in the numerator. Anything that is a negative goes in the denominator. Okay, because that follows, if it's a denominator, it gets a minus. If it's a plus, it goes in the numerator. Okay, so in this case, the natural log x plus 3 squared, that's a positive, so that's going to go in the numerator, x plus 3, close parentheses, squared. And this is a plus, so that x, so this is a plus natural log x, so that goes in the numerator. This is a minus natural log x squared minus 1, so that goes into the denominator, x squared minus 1, close that. Okay, questions there? Well, we still have to bring this exponent up, the 1/3, because that's what we're doing here. Okay, so we got to bring that exponent up. So that'll be natural log, and then parentheses, and I'm just going to move this x in front, x times x plus 3 parentheses squared over x squared minus 1, make that a little bit bigger, x there, and this 1/3 comes up as an exponent. But now we have to change that to a radical, change it from an exponential expression to a radical expression. So this will be natural log, and all this whole thing is going to go inside as the radicand. But we have to figure out what goes here as the root. Well, we said before that x to the 1 over n equals to the nth root of x, right? So whatever's in the denominator, that's going to go in the root. So what's going to go here for our root?
Is it x2 minus 1?
No, it's up here.
1/3.
Yeah, but it's just the denominator. So this is the root. When we have a 1 over n, right? When we have a rational exponent, that becomes a radical. So just the denominator is our root. Okay. So if we had x to the, let's say 1/4, then that will be x to what root? Just
4.
the denominator. Yeah, 4. Okay. All right. So, and then the rest of this just all the radicand, what's inside, x times x plus 3 parentheses squared over x squared minus 1. And that's our answer. That's our logarithm condensed to a single logarithm. Okay, we've gone from expanded, right, to a single logarithm. Okay, questions with that? All righty.